We are going to look at a little example now of finding some one-sided limits and overall limits here based on this graph. Now this graph is a pretty interesting function. It's very piecewise. It's all disconnected, discombobulated here. But this is kind of an interesting problem to look at because as weird as this function is, we can still determine limits based on this graph. So the first limit we're going to look for is the limit as x approaches 2 from the left of f of x. We're saying that y equals f of x here. Okay. So let's see what we're going to be looking at. All right, so we're focusing in on the point where x is approaching 2. So that would be right here. Okay. Now, the little minus sign notation, that does mean from the left. So we want values that are to the left of x equals 2. And that's where we want to approach from. But remember, when we're taking limits, as we're approaching a value, that means we're getting really pretty darn close. So when you're picking a place to start on the function that's to the left of 2, you don't need to start all the way the heck over here. Well, that is to the left of x equals 2. It's really pretty far off in the grand scheme of things. We're more interested in what's happening as x actually gets pretty darn close to 2. So picking to start your function tracing, let's say, from right about here would probably be fine. We don't want to be too far away from x equals 2, but we do still want to be to the left of that value. So I would put a finger on the function right about there, okay? And then we're going to trace along the function and see what happens as we come in from the left there. So I'm moving towards x equals 2 while staying on the function. We're really, really close to x equals 2 now, and it looks like our values are heading towards this right here, which would be a y value or f of x value of 2. And so that is our left-hand limit. It's 2. When you're doing these one-sided limits, pretend that you have no idea what's going on the other side of that special x value. So here we're focusing on coming in towards 2 from the left-hand side. We're going to pretend we have no idea what's going on to the right of 2, that there's this other part to the function, that the function value is actually down here because we don't actually arrive at x equals 2. We're just getting very, very close to it from the left, okay? So it looks like we would come to this point here. There happens to be a hole right there, but we're still approaching that as a limit. Okay. Now let's try another one here. Okay, pretty similar. But let's look at the limit as x approaches 2 from the right of f of x. Okay, so we're coming towards that same x value. This is the guy that we're interested in. All right. But now we want to start to the right of 2. So we want to be on this portion of the function somewhere. And again, you don't need to be too far away from 2. We were really interested in getting very close to 2. So you might put a finger on the function about here. And then we're going to trace along the function, letting our x value get closer to 2, coming in from the right. It would be something like this. And it looks like we are approaching this y value right here at 1. And so that is our limit as x approaches 2 from the right of f of x. It's going to be 1. Okay. Now, let's think about a little more general here. The limit as x approaches 2 overall. So not a one-sided limit, not right hand or left hand, just the limit as x approaches 2 of f of x. Okay, so think for a second. You might think back to our previous video or a couple videos. For a general limit to exist, remember our theorem, we need to approach the same limit from both directions. So our left and right hand limits must be equal. Here, this is all the same x value we're approaching. So as x approaches 2, we would need these two limits to match each other in order for this limit to exist. So since those two limits don't match each other, this overall limit does not exist. Okay, DNE for short. And this is because our left-hand limit did not equal our right-hand limit. Okay, so it does not exist, and there's the rationale, because those didn't match. You could also see that on the graph by using our old approach of putting 2 fingers on the function, one to the left and one to the right of your x value of interest. So maybe put a finger here and a finger here, and simultaneously move those fingers closer and closer together, tracing along the function. One finger would be doing this, and one finger would be, oops, not coming that way. One finger would be doing this, moving in towards x equals 2. And you end up seeing that your 2 fingers are not going to touch each other. So we don't have a consistent limit between the 2 sides. That limit doesn't exist. Okay. Let's try some other ones here. Let's look at, this is just general practice, let's look at the limit as x approaches -3 of f of x. Now, on this one, it's important to note where the negatives are, because notice how our left-hand limit has a little negative sign, but it's up in the superscript, kind of like where an exponent would be. So that's 2 from the left up there. Down here, the negative is down in front of the value. This is just the number -3. There's no left or right about this. Okay, this is just the limit as x approaches -3 overall for f of x. So we would want to approach x equals -3 from both sides. So put one finger on one side of x equals -3, put your other finger on the other side, and then trace along the function and see where those fingers end up. So you're bringing your x values closer and closer to -3, tracing along the function like this, tracing along the function up and down like this. And your fingers should come together, okay? That matches up in the middle there. Those are both approaching a limit or a y value of 1. Okay, so this overall limit does exist. It equals 1. Even though the function is not defined at that point, there's a hole in the graph, our limit still exists. We're still approaching that same y value. Okay. Let's do a couple more here for practice. Let's look at the limit as x approaches 6 of x. Okay. Now notice how this is another overall limit. X is approaching 6. There's no from the left or from the right, so this is not a one-sided limit. It's a both sides general limit. So let's see what's going on here. Here's x equals 6. So you put one finger on one side, one finger on the other side, and you're going to bring those fingers closer together, tracing along the function, see where they end up. So trace, 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 trace. And it looks like they are both coming towards the same value again. So that is our limit value, and it's a limit of 1 again. Now, notice on this one, we threw in an idea that we had looked at before in one of the previous sections. I want to say 2.1. The function has a hole in the graph, but it's not undefined at x equals 6. F of 6 does actually exist. It's just up here. F of 6 is 3. All right, that's f of 6. But the limit as x approaches 6 is not 3, it's 1, like we saw from tracing along the function. So the limit is not what's happening at the actual point, it's what happens when you are getting near the actual point, okay? So this limit equals 1. We'll make ourselves a little note of that though. Note that f of 6 equals 3. Okay, so the limit and the function value are not the same thing. They're two totally different concepts, really. All right. So let's look at another one here. You have interesting spots to look at on this graph. Let's look now at the limit as x approaches -1 from the left of f of x. All right, so we've got two different minus signs in this notation meaning different things. So x is approaching -1, so that minus is just for the negative value. And then this little minus up here is from the left. So x approaches -1 from the left. Let's focus in on -1. That's right here. And we want to come towards that x value from the left, so from over here. All right. So we'll make a little mark somewhere on the function to the left of -1. And we're going to approach x equals -1 from the left. Trace along the function. Your x values get closer to -1. And it looks like we are approaching this point right here. So that would be a limit of -2. All right. We'll do another similar one. You might be able to guess what I'm going to throw at you now. The limit as x approaches -1 from the right of f of x. Okay, so we're still wanting to focus in on x equals -1, but now we're coming in from the right, from values that are greater than -1. Okay, now don't go too far away there, just put your finger somewhere on the function to the right of -1. And we're going to bring the x value closer and closer to -1, tracing along the function. Trace, trace, trace. Okay, it looks like we are approaching this value right here. Again, we're totally ignoring the whole left side. We don't know about any of this. From our right side perspective, all we can see is that it looks like this is getting close to 3. So that's our limit from the right side. Right-hand limit, 3. So to put that together, the limit as x approaches -1 overall of f of x, what is that going to be? I know you know it. If you said does not exist or D&E, you got it. Okay, so this limit does not exist for exactly the reasons that we were seeing before. Our one-sided limits don't match. We can see that really clearly on the graph here. One's down here, one's up here, totally not coming together. So our overall limit does not exist. And then if you were asked for justification, mathematically, we would say this is because the limit as x approaches -1 from the left of f of x does not equal the limit as x approaches -1 from the right of f of x. And there we would have it.